Welcome to this Spotlight interview. We have with us today Dr. Armando Falcucci.
Hi, everybody. Thanks for having me.
So we will be discussing his recent lab protocol paper and the associated protocol in protocols.io. The paper is entitled Practical and Technical Aspects for the 3D Scanning of Lithic Artifacts using Microcomputed Tomography Techniques and Laser Light Scanners for Subsequent Geometric Morphometric Analysis, introducing the StyroStone protocol. Dr. Falcucci is a postdoctoral researcher at the University of Tübingen in Germany, where he completed his PhD in 2018. He's a Paleolithic archaeologist interested in the earliest stages of Homo sapiens dispersal into Europe. He focuses on the analysis of stone tools, which are some of the most enduring artifacts found in prehistoric contexts. He analyzes stone tool assemblages using a combination of methods, such as traditional attribute analysis and more cutting-edge techniques developed thanks to the increasing use of 3D scanners in archaeological research. He's currently conducting a research project funded by the German Research Foundation that focuses on the analysis of several Paleolithic sites excavated in northern and southern Italy, as well as the Near East. Specifically, he's conducting for the first time a comparative study of the archaeological layers dated to the onset of the Upper Paleolithic, which narrate the demise of Neanderthals and the definitive diffusion of Homo sapiens. He strongly believes that archaeological research will advance when researchers will fully commit to open science practices, which boost innovation and cooperation. And this is the reason he published the protocol alongside one of the most numerous data set of 3D models of stone tool artifacts, a digital collection that is expanding through ongoing data recording. So Armando, thank you so much for being with us.
Thank you. Thanks for the introduction.
And let's dig into both the paper and the protocol. So can you briefly explain what the protocol is about, how to use it, and why it is relevant?
Yes. First of all, this protocol is, let's say, the cooperative works between different researchers. The first author of the paper is Dominik Godna, who was a student at the University of Tübingen in our Master of Archaeological Sciences, together with Alexandros Karakostis, who is a paleoanthropologist also at the University of Tübingen. And when we started to collaborate in these tasks, we realized that 3D analysis in stone tools were kind of keen to analyze the bigger artifacts that were recovered in an archaeological site. Why? Because there are several issues with scanning very small lithic artifacts. And so that we decide to explore new ways to scan artifacts using micro-CT technology, microcomputed tomography. And we were able to do so because we have a micro-CT scanner here at the University of Tübingen that we can access to by requesting permission to the university. And micro-CT technology allows to scan very small artifacts in a very convenient way. We published this protocol because it was not done until now, and we wanted to make it things also faster, so to reduce the number of scans, because it's a kind of an expensive technology, but also trying to scan as many artifacts as possible. And so we developed a protocol where we can actually scan sets of artifacts. We did up to 220 artifacts per scan, which is a very cost-effective way to scan artifacts, especially when we consider that with handheld scanners and photogrammetry, we have to spend quite a few minutes processing each artifact alone.
So you mentioned that you decided to publish a protocol because before there was nothing like this. So can you then elaborate on what was the state of the art when you decided to embark in this project? So how people did the collection of the data?
Yes. So 3D analysis in stone tools, so especially in archaeology, is something new. It's something that has been developed. It's been developed in the last few decades, but we had a clear increase in the studies starting from when 3D scanning technology has been more affordable. So more archaeological institutions, more museums, and our university were able to buy those scanners. However, the 3D scanners, for example, the blue light technology scanners or photogrammetry, are not really capable of capturing small artifacts. And when we, for example, excavate a site, an archaeological site dated to the Paleolithic, so I can talk about very old assemblages of the 100,000 of years ago, but also to Holocene assemblages, so dated to about 10,000 years ago on. We usually recover very small artifacts that can be also 10 millimeters in length, in maximum length. And those kind of artifacts are very challenging to be scanned without the use of micro-CT technology. There were, of course, a few published studies on micro-CT scanning of lithic artifacts that we also cite in our paper, but none of those studies actually tried to scan artifacts in batches. So let's say more than 10, 20 artifacts together in order to maximize time and cost of those technologies. And most of the studies published until now were using different scanning technologies. For example, the artefacts spider scanner or the Davis scanner, all the scanners that, however, are not very convenient for scanning those very small artifacts. So our main task was there to try to focus on a different way of scanning, but also trying to maximize the number of artifacts that could be scanned. Because sometimes in archaeological assemblages, we have thousands of artifacts. It might be very challenging to scan each one of them just using a scanner that is capable of scanning one artifact at a time. So the state of the art was that. And since then, new research has been conducted, of course. We are not the only ones that have been trying to to increase the number of scans in using micro-CT technology. For example, there is a new preprint about medical CT scanning. So no micro-CT, but medical CT using scanning bones. So bones that are recovered in archaeological assemblages as well. And trying also to use different post-processing phases and post-processing methods that rely also on more open science software. So the task will be also to try get together researchers in order to even more improve those kind of protocols.
Thank you so much. And then, I understand that the motivation to have this protocol published, it's because it's innovative and you see the potential for use. But why did you decide to go the extra mile and have the protocol not only published in the platform, but also peer-reviewed and published as a formal paper in PLOS ONE?
Yes. So when you look in the, let's say, modern archaeological research, there is now a trend to try to be more open science compliant to open science practices. This means that we should, as archaeologists, as researchers, try to publish all the different steps of our research that has been conducted, especially to understand which are the steps that should be reproduced, but also to understand whether there have been problems during the research process. The protocols, I find that protocols.io is a perfect platform to share research, but also to share ways to go on to expand our knowledge. And when we actually decided to publish a protocol, our idea was not only to share with colleagues, but also to try to make these technologies more available to different universities across the world. So there are step-by-step the step-by-step organization of the protocols also allows you to change little parts depending on which kind of micro CT scanner you're using, or actually to adjust it and also to modify the protocol, which is something that you can do directly on the website, in order to show that there are different ways in which you can achieve the same result, but still can be helpful for others to have a starting point, and then from there start to this. And then concerning your second question about the why peer review is of course the basis of scientific behavior, would I say scientific research. And the peer review process in PLOS ONE also helped us to fortify and to strengthen our discussion and also the results, because, for example, we added afterwards a validation study to this protocol, which we achieved by using a different scanning technology, a very new scanning technology developed by artefacts, with a scanner that is called artefacts Micro. And we actually compared different scanning technologies using statistical analysis in the R programming environment in order actually to see whether our scans were reliable and could be compared to other already available scans that were obtained with other technologies. So the peer review gave us also the opportunity to validate our study and to actually perform more replicable research.
I am pleased to hear that you found the feedback that you got to the reviewers constructive, and that it helped to shape the final version of both the protocol and the paper. And I would like to use this opportunity, this conversation, to dig a little bit more behind the scenes. And I don't know if you can tell us, what were the things, for example, that you tried but didn't work and didn't make it to the final version of the protocol?
Let's say that when we first started, our main challenge was, first of all, how to adjust, how to fix all those artifacts into a single scan. And this is something that is very challenging in micro CT scanning. There is actually a new paper in PLOS ONE that also addresses which kind of support, which kind of materials to use. They are so-called fixation materials. The name of our protocol comes exactly from one of those fixation materials, which is called Styrofoam. And we use this one because it's one of the most available, it's one of the most used for micro CT scanning. However, the first challenge was to try and understand how to fix stone tools in this Styrofoam, and afterwards for the segmentation phase, whether those materials were easy or not to remove. So we actually tried a few different settings, a few different ways to put materials, and then we came to realize that if we used a rectangular shaped Styrofoam, putting lithics on one side and the opposite, we were able to put as many lithics as possible, but also to provide some distance for the post-processing phase and for the segmentation phase. So it was the main challenge was exactly this one, as also was to try and understand and develop a way to record the exact position of each artifact in the Styrofoam body, because you have to consider that each artifact has a single ID, and what you don't want to do is to mix artifacts and to lose track of what you are actually analyzing, because those artifacts come from different layers, different archaeological units, maybe also from different sites. So you need to have a very good control of that. So before starting to use those 200, 250 artifacts per scan, we ran a few tests on how to organize materials in order to be the most accurate possible and to lower the risk of mixing artifacts at the minimum. And as for the Styrofoam, we actually didn't try other fixation materials. This new PLOS ONE paper actually was written by Schaberich, gives us the comfort us because it's say that styrofoam is a very ideal material for most of the scans. So this is a good news for us. But of course, the future research, we should also try other materials, other settings, in order to even more maximize the number of scans that can be done in a single scanning session.
So would then that be the next step to try? Actually, like that's where you see the protocol expanding to try different fixation materials?
Yes, I see. First of all, I see this as a very important point. So try different fixation material and also try different ways to adjust lithic artifacts depending on the size and depending on the geometric features that they have. Another way to expand the protocol would be to try different resolutions, because we use the 140 microns. Our goal for this protocol was to run and conduct geometric morphometric analysis, which try to understand shape variability using different algorithms. And so we didn't need a very high resolution scan for that. However, if you want to conduct other analysis, for example, on the angles of retouching when those artifacts are modified and so on, we might need to try to get a higher resolution. So maybe decrease the size of the styrofoam and get a little bit closer to the scanner, to the micro-CT scanner, in order to get even higher resolution scans. This also first of all depends on the research design. It depends also on the time that you were allowed to use the scanner. It also depends on the budget that you want to invest on that. But what I can see is that a future step would be to actually go try to get a little bit smaller styrofoam bodies and to get closer to get even a better resolution of that. And this is something that should be tried either by us or by other researchers that are interested in more fine-grained research questions. Yeah. And
going back to the protocol as is currently, what are, for the reader, the most critical steps in the current protocol?
So the most critical steps would be, of course, to first of all to prepare a styrofoam body that where the materials that you fix are not moving at all, because you need to have a very stable lithic artifacts fixed on the styrofoam when the micro-CT scanner is rotating. This is very important, because otherwise you're going to get some, let's say, artifacts or other problems during the scanning. The second phase would be to when you're doing the post-processing phase and when you are trying to segment those materials, to find the sweet spot between removing all the styrofoam, but while leaving all the lithic artifacts there, especially when we are talking about very thin artifacts, when we are talking very translucent and small artifacts. Sometimes you might incur in the risk of removing a part of the edge when you go too much into this direction. So it's my suggestion would be to try different settings and to try to play with the different settings in order to be able to remove all the styrofoam but leave most of the artifacts there. And this is one way that one thing that might be a little bit challenging at the beginning, but we tried actually to show different steps in the software Aviso in order to fulfill those requirements for subsequent analysis in the best way as possible.
And yeah, it's been a real pleasure to talk to somebody who is so young in his career and yet so committed to embracing open science. So I would like you to tell us what has been the implication of getting this protocol published and the associated paper for your career. What is the significance? What has been the significance?
Yes, the first significant step that I achieved through this protocol, I would say, was to actually embrace open science. because you know, in archaeological research, sometimes open science is a little bit challenging. There is somehow people are somehow scared of sharing data sets, sharing 3D models, sharing data. Why? Because then publication efforts might be a little bit more loose, and also because there is a little understanding of open science practices in our field. I can see that, however, things are changing, and I'm happy to be part of this new commitment to those kind of practices. And of course, the major step was that we were able to produce a very large data sets of 3D models that we are actually using daily to conduct our research and to publish new articles. So the major scientific step for me was to have a data set that I could use to publish research and to do research even during, as we know, during a period in which traveling during the COVID pandemic was very difficult. So I would say that I'm very happy that I was able to scan those artifacts in order to be able to continue my work while not being able to travel to analyze materials. And I can see that our protocol has also got some attention. These data sets of 3D models has been already used to conduct new research and in using some of the artifacts in order to address some questions. And also new scanning protocols have been published, as I was mentioning before. A very nice one is the one from Jezi Woodley, which is it's a preprint that will be hopefully soon published. This is from the Minnesota University lab, and it's a very nice protocol. Why? It's because it also uses Python for the segmentation. So using Python, it's a major step forward also for our protocol, and this is what I would like to do with them also, to try to get our scans together and try to use the segmentation algorithm they published in Python. Why? Because if we start using non-proprietary software, this protocol might even more be enhanced. Why? Because when we have scanned those materials, we can use Python, which is freely, it's open source, can be accessed by everybody worldwide without paying any fee. So even more scans, even more data sets can be published with it. And I'm very thankful for that algorithm that has been published. And I really look forward to collaborating with those researchers to try make things even better.
Yeah, and I can see how incorporating exactly open source software into the pipeline will make the protocol much more accessible and translatable to settings in which funding could be limited, right? And just, Armando, it's been a really nice conversation. Before we wrap up, is there anything else that you would like to share that we haven't discussed so far?
Concerning the protocol, I would say that we actually covered most of the points, and we also covered what can be done and is being doing by other researchers to go on, to continue in this direction. What we are now doing is to create even more 3D models and to publish those data sets in Zenodo and trying to get more models available. So I would like those models to be used even more. So this is the main, my main, let's say, scientific desire is those models are accessed and are actually shared in different platforms in order for researchers to know they exist and to be used for geometric morphometric analysis, for experimental archaeology, and to answer different questions related to modern and human behavior in the past. So this is what would be very nice to see in the future. And the visibility of the protocol is helping us to do that.
Perfect. Well, thank you so much, Armando. I won't take any more of your time. I think this conversation is going to be very useful to the users of the protocol, but also to the general archaeologist. And with that, I will just bid farewell.
Thank you so much.